The next report will made our friends. Alexander Kilin, Yuriy Karavaev, or Kirill Yefremov, who will be make this presentation.
Oh,
Kirill Yefremov, I see.
yes.
Please.
Do you hear me? Okay. And slides. Okay. Do you hear me?
Yes, yes, go ahead.
Let us start. Okay. Hello, everyone. Let me introduce myself. My name is Yefremov Kirill. I'm from Kalashnikov State Technical University. Today I would like to present you our research which called experimental investigation of the controlled motion of a roller racer robot. Roller racer, it's a toy for children and look like this, and consists two parts. First part, it's a big part for sitting, and the second part, it's a smallest part for steering and moving. And as you can see, both of this platform connected through rotated joint and have freely rotated two axes on the same freely rotated wheel, which place it on one axis. This axis for first platform, or for second platform, and this axis for first platform. And can you see my mouse or not? Yes?
Yes, yes.
Oh, okay, thank you. This is a kinematic scheme of roller racer on the plane, and P, it's a point of connection, first platform and second platform. A1 and A2, it's a center of mass for corresponding platform, and C1, C2, it's a center of wheel pair, and x1, y1, and x2, y2, it's a coordinates which depend on the platform. Onto this slide, you can see equation of no slipping condition. It's very important for this research, and for in state of generalized velocities, more is suitable, use quasi-coordinates v1 and v2. V1 and v2, it's velocity of point P, which velocities of point P relative x1 and y1 axis. For important for us, it's v1. It's a speed of v1. It's a speed of roller of first platform to forward and backward, and v1 the different denote like the answer this equation, and depends from coefficient of friction, of moment of inertia, and angle between of platform. This is a system of equation depend from v1 and angle between platform and time. define x, y, and z coordinates. It's an angle of roller racer on the plane, and x and y. It's a path of motion of roller racer. For investigate of roller racer, we make a prototype. This type of robot. As you can see, we place it some kind of like a cup to the both side of second platform. It's for change moment of inertia second platform, and size of diameter of this cup matches with metal peel. It's a this four metal peel look like a short metal cylinder. Every cylinder have a mass 66 gram, and every cup include 4 metal peel. This is on the top of roller racer. It's a reflected marker. Reflected marker we use for track it this kind of robot. We use a Viken system for motion capture, and this marker place it on the point of P. This is a parameter of our prototype. It's an important parameter for our research. It's a mass of first platform. It's a ½ kilogram. Mass of second platform. It's a quarter of kilogram. And mass of metal peel. It's a 66 gram. And for this table, important parameters is the coefficient of friction K, which equal quarter, and it's all. And for control this type of robot, we use a periodic function. As you can see, this toy have only one rotated joint, and this second platform can be used like a steering and actuate like a steering and actuator joint. Push left side and right side. We push with pushing left and right side. We can periodic oscillates of second platform and move forward to forward direction, and for control we use this periodic function where P0 it's a shift from a y-axis. It's a t-axis. It's a period of our function. A it's an amplitude, and phi it's a shift. Amplitude and period give for us velocity of roller racer, and shift of this function give for us steering of motion. This is a moment of forward direction. This is average speed and average and interval of confidence. This is a graphic relation between speed of roller racer, the dependent ratio of moment of inertia, first and second platform, and the amplitude of oscillation. As you can see, moment of inertia it's when we change moment of inertia, this is onto this point, we provide the experiment without metal pill. This is onto this border. You can see experiments with one metal pill to both sides from for second platform. This is two metal pill onto both sides of second platform, 3 metal pill, 4 metal pill, and if we heavier second platform, our speed highly increase. And interesting moment, it's a speed without metal pill, and in this is surface, blue surface. It's a computer modeling experiments, and you can see increase our speed, and after some point our speed decrease and move onto negative side. In the practice, it's a gift for us movement to backward. Onto this part of this graphic, we move forward, and after 1.0 radian amplitude, we move to backward. With one mechanical initial conditions, we can move forward and backward side. Here you can see a change moment of inertia for 2 pills, for 3 pills, and 4 pills. This is average velocity with confidence intervals, and this is numerically experiments velocity. And second set of experiments, it's a dependence velocity of roller racer from t from period of motion and amplitude. And as you can see on the table, period of motion, we use 1 second and 2 seconds, and amplitude we use 40 degree, 30 degree, 45 degree, and no 15 degree, 30 degree, and 45 degree. And if we as you can see, if we decrease time, and increase amplitude, our velocity our velocity decrease. And last of experiments, it's a movement along curvature trajectory, and it's for 5 degree, 10 degree, and 15 degree offset. And conclusion, we investigate a robot with one actuator, only one actuator, and on the future work, we want more investigate more details on this robot. Thank you for your attention.
Thank you for your report. And I again ask everybody who does want to ask a question. Please, Evgeny Magid.
Kirill, thanks for your presentation. I have a question about your Vicon marker. I have noticed that you use only a single marker. It seems that a single marker is enough only to track the position. And moreover, if we have any occlusions, you are in trouble. Did you try to use more markers, or you do not need to have more markers?
Oh, thank you again for your question. We use Vicon not work with one marker. Vicon work for working in Vicon, we need to use minimum 3 markers, and but put off other markers for take a photo.
I see. Okay, thank you. Because I worked intensively with Wycon a couple of years ago, and I thought that maybe new model can work with a single one. So it was a surprise for me. So now you cleared the question. Thank you. Thank you.
Oh, thank you. We use
Thank
old
you.
model of Wycon.
Okay, the next question, Professor Kono. Please, ask your question.
Okay.
Я должен.
I can hear.
Can I hear me?
Yes, I
I
hear
hear
you.
you. Please ask your question.
What is your research purpose, for example, for developing a new LoRa laser for kids to have fun playing?
Oh, sorry. I not so clearly understand your question. Please repeat it.
What is your research purpose?
I ask you to ask your question in chat. The time is over, unfortunately.